Swayam Prabha. Digital India. Educated India.
Good morning, everybody. Welcome to Vacuum Technology Process Application course in Module 1, where we are discussing introduction and basic concepts and applications. And in the lecture 2 of this Module 1, we will be discussing history of vacuum technology. As you all know, in the lecture 1, we have covered basic definitions and natural vacuum around us and popular introduction to vacuum we have given. Before we go into more serious stuff like production, measurement and system design, it is customary to understand history of vacuum technology. So, the concepts covered in this lecture are related to history of vacuum technology. Call it pumps, measuring instruments or applications, what happened when, because this is very important. How electrical applications came, how electronic applications came, how food processing applications came, how mechanical force applications came, and how people started discovering various gadgets, pumps, some people, measuring instruments, some more scientists, and applications, going back and front, revising the things with constraints. So, varieties of developments took place in vacuum technology to suit the needs of various applications. 100 years back, the Röntgen discovered X-rays. It was possible only because vacuum was there. Only in vacuum conditions he could make high speed electron beam to hit a target and produce X-rays. Similarly, Edison could discover bulb, first time producing light out of electricity because of vacuum. Similarly, semiconductors, first chip or first even PN diode could be made only because these semiconductors are processed under vacuum conditions. Most of the engineering coatings, even for our food processing applications or even packing applications, even bangle coating or various types of coatings, protective coatings, etc. These coatings were not possible unless you have a vacuum chamber, vacuum pump, vacuum measuring instruments, controls. So, these things have been developed over a period of time in the history. So, if you try to understand this historical development, it will give us a feeling, and later when we deal with serious concepts in production, measurement, troubleshooting, system design, application, we will become, it is already friendly to us. Vacuum technology is already friendly to us. So, we will not feel strained. That is the idea behind covering this history of vacuum technology. The history starts from Galileo, as usual. He is a great man. I am not going to give more description about it because all of you know who is Galileo. And he at 1630, 16th century, he has produced force concept out of pressure difference, one side vacuum and this side vacuum, other side atmosphere, and to lift weights. Look at his imagination 400 years back in a scientific manner with proper sealing in a cylinders with pumping mechanism, how he thought over, but it was a fact. He could make force due to pressure difference. It is nice of him to get the right point that pressure difference into area is the force. Till that time people were not knowing whether it is pressure difference or pressure ratios. There were several properties which change as a function of pressure ratio, but force changes because of pressure difference. That is why in vacuum one side 760 torr, other side 10 torr or 1 torr does not matter, because 760 minus 1 is same as 760 minus 10 power minus 10. So, you do not have to produce very high vacuum levels to produce forces. So, this concept was clear to Galileo 400 years back. So, that is how history starts. This is the mechanical engineering application of vacuum technology. An associate of him, Torricelli, in the same period 1644, he developed a device to measure this vacuum using a famous barometer. Of course, this is there included in your textbooks in school. It is a inverted seal tube in a trough of mercury, and when you try to evacuate the other top side of it, which is closed like here, then the atmosphere is forcing here. So, the mercury gets lifted and you will start getting 76 centimeters height of mercury column. Beyond that it is not going, because atmosphere could pressurize, could apply force up to that level. That is why 76 centimeters or 760 millimeters of mercury is called atmospheric pressure. These concepts were clear to Torricelli, who went to a hillside and inverted those times. He did it not only with mercury, with water also. When you do this with water, you all know what happens. This is a typical 11th class question, because you have to multiply by the relative densities some 13.5 times. You will get 10 meters height of water column. If it is mercury, it is 76 centimeters. If it is water, it will be 10 meters. That is why in most of the chemical industries you will see most of the equipment are at 10 meters height, because barometric legs from the intercoolers and various cooling equipment, etc., they will be drained automatically up using barometric legs in a natural control manner. That is because vacuum can create at the best 10 meters equivalent height of water column. So, this was already known to Torricelli. That is why a unit came after his name called torr in vacuum technology. I am trying to link the history with the modern trends as well as units and concepts involved in production and application. Then within 2 years Pascal came. He is a very famous man. There is again unit after him, Pascal's. He also made different types of measuring instruments to measure this. You will see at those days there are two types of people. Some people produce, some people measure. Nowadays we call it as quality control, etc. Without measurement, physics is study of measurements. All these people are scientists. That time there was nothing called physics or chemistry or mechanical engineering, electrical. Nothing is there, it is science. So, Pascal made different types of barometers which are handy to measure these vacuum levels. This is 400 years. You see, if you look at carefully, 1630, 38, 44, 46, within 10 years, so many discoveries. And all of them are great people, Galileo, Torricelli, Pascal. Units are there after them. Then within another 4 years, a mechanical engineer, those days, we cannot call mechanical engineer or anything. There is a, we can call now in present day scenario, is called Otto von Guravik. He is a very famous man. He created first vacuum pump in the left side using some wooden things and some seals and leathers, and then pulling it like our cycle pump. No? When you try to pull it up, vacuum is created, air is sucked in, and the valve tube is closed to one side, and when you are trying to pressurize it, the positive pressure goes into the tube, etc. All these concepts. Now also it is not clear to most of the students, but those days it was 400 years back, they could make it and they produced vacuum. And the people around us were not believing that this atmosphere has got force, it can apply force compared to the vacuum that we need to create. There is a pressure difference. People are not believing, what here? There is no force around us. So, what he did was, after producing first vacuum pump like this, he called all the people. This is a famous Magdeburg experiment. If you carefully look at it, he took two hemispherical surfaces without any nut and bolt. They just connected with a leather seal, and both sides they applied few horses, and asked, that means like a tug of war. So, horses could not pull out and separate these two hemispherical things, because there is a vacuum he has created using his own vacuum pump. That means, on these balls, both hemispheres, there is a lot of force. 1 square centimeter, there will be 1 kg force roughly. So, huge force is there to push it together. So, the horses connected on either side, they could not pull it apart, even though they are not tightened with nut and bolt. And you can imagine, if you try to remove this vacuum just by putting a valve open, remove the pump and vent the inside, immediately it will, both the things will cover, even horses need not pull at all. This famous experiment suggested as the force concepts, which is later used in stopping a train using vacuum brakes, and later used in precise lifting in electronic industry, and lifting and transporting in various mechanical industries, or drying or exhausting various dangerous vapors in chemical industries, etc. So, these concepts came that time given by Gurovic. This is mechanical concepts. So, production, measurement, system design go hand in hand within 10 years in 16th century, 17th century. But later 200 years nothing happened, because electrical engineering was not there, electronics definitely not there, that is only last 50-60 years, computer science no, last 60 years all of these high-tech disciplines came, electronics, computer science. Okay. So, vacuum was responsible for all these technologies. After 200 years, 1874, Charles Baines has invented a rotary vane pump. I will discuss how it works later when we go for production, to produce good vacuum using a structure called vacuum pump, and it is user friendly. So, these pumps can be connected to anywhere within smaller volumes or larger volumes, depending on the application, you can produce vacuum. That is how technology started with, again production, measurement, application, again production. It goes hand in hand. Then the famous man Edison came. First time an electrical application came. So, what people were trying to do, I am not covering Faraday, etc., but they are very great people, they produced electricity, that is a different thing. Since we are talking about vacuum technology, I am taking only those famous people who are relevant to vacuum technology. The invention of bulb by Edison. Edison is very famous for thousands of discoveries, but those days there was no patents or such recognitions, but he is well known, nobody needs to recognize it separately. First time in 1879, he was successful in producing in a glass ball a small filament through which he passed the current, and it became red hot, but the filament is not oxidized because it is evacuated, and the vacuum also reduced heat transfer from the surroundings, thereby the I square R energy into time is good enough to produce high temperature in the filament, and the electrons inside the filament get excited, taking the thermal energy to the higher orbits, and when they come back they emit light. These concepts were known to him, but how do you realize it? He struggled. When he finally put evacuating vacuum enclosure surrounding this filament, he could instantly pass current without oxidation of the filament, without heat transfer to the ambient, and he could get light immediately. You can see the satisfaction when he produced first time light to this world, and that was possible because of vacuum technology. Then immediately 20-30 years later, when Pirani came, he said, okay, this is the time for me to improve the measurements. So, application, production and again measurement. He invented Pirani gauge in thermal conductivity principle. I am not going to describe the principles because there is a separate session for it. This is just a historical development. So, again measurement came. Then again production, because that time they said 10 tar is good enough, 760 tar, 100 tar, 10 tar, 1 tar, but rotary pump 0.1 tar, 0.01 tar. So, more than enough. That means 99.9999% of the gas has been removed already. So, vacuum is good, everybody was happy. If they were happy like that, today electronics would not have been there, dynamics of electron which is called electronics would not have been there, semiconducting processing would not have been there, computers, cell phones definitely not there, most of the modern things would not have been there. That is why they were not satisfied by removing 99.99. They used diffusion pump, that we will discuss the description of it later, using diffusion pump. They produced 10⁻⁵ tar, that means not 1. See, from 760 tar when you come to 1 tar, already lot of gas has been removed. But if you remove further molecules again and again, you will produce better and better technologies. That is why ultra high purity is very important. Just like modern drugs, parts per million impurities are not allowed. Similarly, semiconducting and electronic processing and space and nuclear technology, parts per million impurities are not allowed in the gaseous phase. Then only particles will be accelerated without any collision and to produce nuclear fission and fusion. Then only it is possible to simulate deep space conditions so that you can qualify the satellites to go up. So, this was a never ending story. So, Gade discovered a diffusion pump produces 10⁻⁵ tar. Then came hot cathode ionization gauge to measure these high vacuum gauges. Then Penning produced cold cathode ionization gauge. I am little faster, but I will discuss these things more in detail when we describe gauges in detail. Gauges means vacuum measuring instruments. So, these are series of measuring instruments, pumps, instruments and again applications, again pumps like that to produce still better, still better. Then came Baird-Alpert gauge, which is most popularly used nowadays to measure ultra high vacuum levels in electronic and space and nuclear industries. Then they produce ion pumps to make a pump inside a body and send it along with it. There is no need to separately connect a pump. The chamber to be evacuated contains a small pump inside attached to that. Such pumps are called ion pumps. We will discuss later in detail, because there are sealed off devices in electrical vacuum interrupters in high voltage transmission lines, waiting for a fault to happen, and it will open thousands of amperes at hundreds of kilovolts voltage. It is not possible under air. It will produce spark, arc, lightning. So, these vacuum interrupters have got built-in pumping by Gathering process, etc. at 10⁻⁸ tar. These are called vacuum interrupters here and there. And if you link it with proper control instruments, that is called switch gear. So, these things were possible only because of vacuum interrupters. And ion pumps are used nowadays in X-ray types, etc. to have a continuous dedicated pump built in. What we think we will get a X-ray tube, but it has got pump inside. So, these concepts we will see later. When you continue with history of vacuum technology, then came one Roots blower. Initially, Roots has discovered this blower for positive pressures, for industrial sirens or compressors having maximum volumetric displacement, etc., etc. He never thought it will be used as a vacuum pump, but later when you reverse inlet or outlet, people today could produce vacuum pump out of it. So, in vacuum technology, it is customary to recognize Roots, who discovered Roots blowers. They blow air initially, but now it is used in dry vacuum pump technology. Then Becker is a very famous engineer who could produce high speed rotation of lakhs of revolutions of a mechanical turbine to produce turbomolecular pumps. I will describe it in detail later because it requires a lot of understanding. Then Atlantic Fluidics. So, they produce liquid ring pumps for day-to-day applications of 20 torque, but which are very popular in pharmaceutical and chemical industries. Cryopumps, ultimate pumps, where you don't remove gases as gases, you condense them and as solids. These are very popular cryopumps. Cryogenic production requires vacuum technology, but once you produce cryogenic temperatures, you can produce vacuum out of it. That means vacuum helps cryogenics, cryogenics produce vacuum again. These things are extensively used in semiconductor industry and space technology and nuclear technology nowadays. These are all commercial products available. Claw pumps and scroll pumps and screw pumps have become very popular recently. That means they are not very high vacuum pumps, but they are dry pumps. They don't require lubrication for their operation. Their style of operation itself is different. So, technology is again reinventing more and more new things. One is quantity of vacuum, other is quality of vacuum. You may have 10 power minus 5 torr, but without oxygen, that is better vacuum. 10 power minus 7 torr with oxygen, quantity was better vacuum, but oxygen constraint point of view, it is not a better vacuum. So, if your application does not care about oxygen concentration, then you can, they only want better and better vacuum levels, you can have that. But metallurgical applications, it gets oxidized. Metal casting, melting, all these aspects, people do vacuum furnaces nowadays. Highest, purest metals, alloys are manufactured under vacuum conditions. Silicon, for example, if you try to melt it and cast it for producing the starting material of IC chip, it will be silicon dioxide, which is a sand. It is no more semiconductor, it is an insulator. So, production of this ultra high vacuum right from the beginning should be done in a dry manner. Nowhere water vapor or oil vapor is allowed. Such constraints are coming nowadays. That is why dry pump technology suddenly has come up after producing ultra high vacuum technology already. Now, again going back to 10 power minus 2 torr and producing even from atmospheric pressure, but this time these pumps are unlike rotary pumps and diffusion pumps, they produce vacuum without any oiliness. Similarly, removal of moisture with air blast concepts and with various types of degassing mechanisms, with cryopumps, varieties of constraints are creating necessity for varieties of pumps. So, production, measurement, troubleshooting, system design, application, these are continuously changing depending on the need of the society. What are the present needs of society? You produce electronic circuits, mobiles, TVs, computers. You also produce defense oriented equipment, whether it is nuclear bombs or whether it is nuclear energy for power production, or you require space technology to send satellites to the deep orbits to produce geostationary orbits, or even weather forecasting. All of them require vacuum technology. If there was no vacuum technology, none of these technologies would not have come to this level at all. We will prove it when we try to discuss these applications in detail at the end. What I wanted to highlight here in the history is very interesting. It is a story. Story is, it started from vacuum somewhere with Galileo. Today, vacuum technology is encompassing in almost every sector. High tech, medium tech, low tech and day-to-day applications. You may say, sir, how? Morning you get up, you take Nescafe coffee, it is manufactured using vacuum technology. You make a juice out of it and dry it under vacuum, remove the moisture heavily, if required freeze drying, so that aroma of the coffee will not go out, and that whole portion is scratched under vacuum and kept it in a bottle. So, that is why whenever you open that box, immediately it is so much hygroscopic, immediately water gets contaminated. That is why instantly it absorbs water. So, instant coffee is possible. Okay. So, coffee is related to vacuum technology, around 10 torr or 100 torr maybe, depending on the water level removals and purity levels. Then you come to the drawing room, you look at the TV, or you make a cleaning, vacuum cleaners, you require vacuum. TV, all the LCD displays or LED displays or the original tube type of things, all of them are highly utilizing vacuum technology. If you have LCD displays, between that if moisture and all not removed, you will get patches there. So, TV tube requires. Then immediately computers, laptops that you are using, they are all manufactured using chips. Chip is what? It is basically a semiconducting two-dimensional structure using thin films. Using VLSI, you make different fine aspects of it, and finally you dope with different impurities p-n type and make p-n junctions and join them to make gates or switching devices, assemble them in a motherboard and with all necessary input output peripherals, you will start getting computers. So, starting point was vacuum technology where silicon is processed. So, today semiconductor processing, semiconductor application to make various electronic circuits are intricately related to ultra high vacuum pumps. That is why there are lots of companies who produce vacuum pumps for semiconductor industries. Similarly, pharmaceutical industries, earlier it used to be only distillation and drying of intermediates, but today molecular distillation has come. Each molecule is distilled. That is possible only if the distance between the evaporator and the substrate is more than a particular distance. So, the mean free path concepts we will introduce later. Then only molecule wise it will be distilled. It will not come across with any other thing. It is no more like a gas that is going and condensed. It is a molecule that is being distilled. So, these are very useful in most modern costly drugs for cancer and corona and various other applications, where long chain molecules are there. And long chain molecules cannot be, separation techniques involved in this manufacturing cannot employ high temperatures because they will crack the products. So, they have to be boiled because boiling point goes down with water. At room temperature, I can make this water to boil because boiling point comes to 20-30 torr if I can produce 20 torr above this in a closed container. This is used in pharmaceutical sectors. Metallurgy, if I melt or casting iron or steel or aluminum or zirconium alloys, etc., in an oxygen atmosphere, they will be oxidized. They will be powdery ceramics. So, you cannot make these things operations without vacuum technology. So, metallurgy, electronics, space, nuclear, processing, finally food processing. Nowadays, all the food products are packed under vacuum conditions. The salt that you are taking, it is vacuum evaporated salt. The coffee powder that you are taking, it is also vacuum freeze dried products. Freeze drying is getting importance in medical sectors in various applications. We will discuss those things detail in later. Today, scavenging this air to make these impurities out, the corona type of impurities, they are exhausting it using vacuum technology with suitable bacterial filters, etc. So, we will cover that also if time permits in vacuum conditions. So, with this historical background of vacuum pump production, vacuum gauges for measurement and vacuum applications in various sectors, we get a feel of the importance of vacuum technology. So, today's lecture you have understood the historical background behind vacuum technology in various modern technologies, because what was yesterday's science is today's technology, and when it becomes mass production, it becomes tomorrow engineering. So, we are now in the process of developing various technologies. We have to take scientific concepts, scientific fundamentals and go into the futuristic things. For example, quantum computing, all these things, highly scientific related concepts right now. After some time when they become matured, it becomes technology. When they become mass production, that becomes engineering. So, present day semiconducting device, cell phones, etc., 20-30 years back, it was scientific. Within the laboratory, a lot of research was going on. So, technology is a clean technologies, green technologies. More and more when we talk, you cannot avoid vacuum, whether it is electrical, electronics or freeze, chemical or pharmaceutical or nuclear or space, name whatever, metallurgy. With this introduction of historical background, linking it to applications and production, measurement and system design, troubleshooting, in the next few classes, we will go in detail of each aspect, production of vacuum, various pumps like that. But before that, it is customary to describe these applications very briefly, so that you get a tempo of it. So, I will spend maybe 2-3 classes discussing still the basic concepts. But one thing I want to tell you is, all the basic concepts cannot be covered here. When you discuss production, we will relate production related concepts like that. So, though I am telling basic concepts here, it is not complete at all. Okay. Thank you very much.